This is a video on how to work program 29. And again, this video assumes you've looked at the notes for, I apologize for the April 13th notes, not 16th, the notes for this week for chemistry, and you know the gas laws, you know what STP is, you know that PV equals PV, V over T equals V over T, P over T equals P over T, and PV over T equals PV over T, the combined gas law. So this is how you work program 29. So first of all, when you read the problem, it says if 180 milliliters of gas at 7 atmospheres is changed to 6.5 atmospheres at constant temperature. So there's no T, so it's just PV equals PV. And you have probably learned this, that Boyle's law is an inverse relationship. If the pressure goes up, the volume has to go down to keep it constant. Okay. So how do you work this problem? You write P1 V1 equals P2 V2. And it's just nice to write them over here to see this is 1 and 2. Sorry, this is 1 and 1. This is 2 and 2. So P1 V1 equals P2 V2. 7 atmospheres times 180 milliliters equals 6.5. And you can see if the pressure goes down to 6.55, the volume has to go up. You just multiply this times this, divide by 6.55. V2 equals 192 milliliters. PV equals PV is an inverse relationship. Okay, the rest of these relationships are going to be direct relationships. So problem number 2 talks about a problem at constant pressure. So if constant pressure means I could put 1 atmosphere on both sides, they would cancel out. The simpler form is V over T equals V over T, which is Charles' law. And of course, if you've read the notes, you know that the temperature must be in Kelvin. The Kelvin scale is related to the absolute temperature scale, where the higher the temperature, the higher the molecular motion. Because of course, if a gas is hotter, it's moving faster and it wants to expand. That's why volume and temperature are directly related, just like P and T are directly related. So down here it'll say P over T equals P over T, same kind of problem, just cross multiplying. So you put V over T equals V over T, but the temperature must be in Kelvin. Remember to add the Celsius plus 273 to get Kelvin. So 50 milliliters over 472 equals 247 over T. And you can see it's about 5 times as much, right? So it's going to be 5 times the temperature when you cross multiply. T equals 2332 Kelvin, which is a very high temperature. Okay. And then there's a third kind of problem with P over T equals P over T. Just work it the same. It's a direct relationship, just a proportion. Okay, I recommend when you do this program, if you get a problem that says STP, do it last. Okay, do one of the others, and then when you're finally ready, then do one problem where it's STP. If you've looked at the notes, you know that standard temperature and pressure is the freezing point at standard pressure. So the STP is 273 Kelvin, which is 0 Celsius, and 1 atmosphere. So it says if 207 milliliters of gas at STP, you know the temperature and pressure, is heated to these other conditions. So there's the P2, we don't know the V2, and we know the T2 add 273. This is a little bit harder problem to solve. P1 V1 over T1 equals P2 V2 over T2. So 1 atmosphere times 207 milliliters divided by 273 Kelvin equals 7.86 atmospheres V over 574 Kelvin. Now, when you solve this, there's 2 ways to solve it. The first way is to cross multiply this, and then cross multiply this, which will give you this times this is 2145.78 V equals 118818. Divide by 2145.78 and you get 55.4 milliliters. The second way to solve it is to take this over this, which is 0.758, and take this V over this, which is this divided by this, is 0.01369. Notice how I have at least 3 or 4 sig figs. So when you divide by the coefficient, you still get 55.4 milliliters. So I don't care if you cross multiply or just like reduce this fraction and then divide by this coefficient. It's going to give you the same thing. I don't care which way you do it. Just pick one and do it right. So this is a way to solve those problems. Now again, I'm going to recommend you go work one of the PVs, go work one of the VTs, and then come work the STP problem. Don't start with this one. It's a little bit more involved. All right, so give that a shot. Again, this takes a little bit more time and effort. So I expect people to program 28 a little bit easier, do it on your own. If you have questions, you're going to contact me or contact other people. So first, you're going to contact other people, and we'll talk in the video chat on Thursday. So give it a try and then spread your knowledge if you know it. All right, thank you.